Hi everyone. In this video, we are going to talk through using do files in Stata. Essentially, when we think about a do file, it's just another way, Stata's way of saying a program. Basically a record of all the commands and actions we want Stata to run, such that when we come back, we can pick up where we left off, or at any time we can run all of the commands from start to finish, and it will always do exactly the same thing and always give us exactly the same result. This is going to be very important in terms of saving us time, being more efficient, and then also ensuring that the analysis we do is replicable. If I have a do file and I run it, I should get the exact same results as if you run that do file. And that allows us to be able to compare and share results in a really fluid way. So what we need here are two files. The first is a data file. When you click on it, it should save to your downloads folder. You can see mine has a little 2 parentheses because I've downloaded it a few times. And what this is our data set. You can see it hanging out in my file here. I'm going to copy it and I'm going to go to my Econ Lab folder, Labs, and I'm going to paste it in here. Oh, it's already there. So I'll paste it. Now there's 2. There. So I'm taking that file and I'm moving it there. This is a subsample of the American Community Survey, which is conducted by the U.S. Census Bureau. You can think of it like the census, except that it's conducted every year and it's not conducted with everyone, only with a subsample. That said, even though I've given you a 2.5% sample of this data set, there's still 85,000 people there. So I think we can do a lot with that. Then we're going to have a do file template. Essentially, this is a text file. And the extension, the little thing at the end, is .do. Sometimes in your browser, if you click it, it will download it like this, which is what we hope for. It might open it in your browser. If it does that, what you can also do is you can right-click and you can click on Save Link As. And then you can move to your file, your folder, and you can just save it in here. Now, when you go into your folder, you should see your template and your data file. Or if you downloaded it, you can just open the download folder and drag it in as we did before. These are the 2 things we're going to need. So I've got a whole bunch of commands here for us to look through. You might want to come back to them. If you want more examples, more resources, I find these kind of Stata cheat sheets to be very helpful. You can print them out, keep them near you, keep them close to your heart. They kind of highlight a lot of things that Stata can do, and what I find most useful really is a lot of the basic syntax and structure of commands, because that's sort of something that it's not so much about memorization, but about understanding. So essentially what we're going to be doing here is making sure that our analysis is replicable and documented. I'm not going to tell you here, but you can read along, and there's a whole story about some macroeconomists coming to some really strange conclusion because of an Excel error, an error that wouldn't have happened had they used a proper program like Stata, R, Python, anything where we can check our work and we're not subject to not accidentally drawing things down. So I've got a lot of text here. I think what's most helpful is if I actually open a file and work through it, and then we can talk through our tips and what that means for us. So you're going to have a file like this. We're going to open it up. When you double click on it, it should open in Stata as a separate window. So it's not embedded in this one, it's just floating around. And this is a do file editor. Alternatively, you can always click on the button at the top called do file editor, and there you can make a new one and just have a blank one like that. So I'm going to double click and open this up. And what you can see here is a giant window that just looks like a plain text file, except it's very colorful. Stata wants to color code different things to make it more readable. If you're familiar with other languages, it's going to look a little bit different because everyone has different standards and norms, but the idea is still there. So, things to know. When we set up a do file, you'll see a lot of green. Greens are comments. They're notations to yourself. They're things that can be useful for yourself, for me, for other people you might want to share this file with. And there's 3 ways to do them. These 3 ways are outlined over here, but I'll show you here. So the first one, let me just start typing. So I'm just putting in some things in my file. I wouldn't do this. So I just typed some text. You can see it shows up black. That just means that Stata is going to try to read it. If I want to run my file, I can do this by clicking on the do button, do, or execute. You can see I have an error because it tried to read this, but that's not a command because I just typed some words. And you can also see some other options if you want those too. If you are using a PC, you can hit Control D and it will run your do file. If you are using a Mac, you can hit Shift Command D, and that will also run your do file from start to finish. That can be very handy. So I might want notes to tell me what I'm going to do. So what I can do is I can put them in a comment. So the easiest way to comment something is to add an asterisk, right? Just like that. So now it turns green. Stata will not read this. See, it just ignored it. I went right by it. This is helpful because you can comment out a whole line. You can also make pretty little stars. If you want to have a comment alongside something, so for example, if I want to display 4 plus 4 and I want to add a little comment, this won't work. See that it thinks that this asterisk is part of a multiplication and it won't work. And so what we need to do then is a different type of comment, which is a double / comment. You can have a double / comment over here as a full line, or you can embed it in the lines. You can use tabs to make it pretty if you want. So this can allow you to comment things mid-line versus an entire line. And the other way we can do things is with blocks of code. So up here, I like to start a do file with a header about what the name of the file is, what it's about, what's happening, maybe when it was last updated, etc. And the way that we can comment this out, so I don't have to do everything, is I can type a / and an asterisk to start the comment, and then an asterisk and a / to end the comment. Other things to know. If you are someone who has coded in other languages, but not Stata, one thing that is a little bit different about Stata is that it reads each line as a new command. So this is different from languages where you have to use a delimiter, some sort of punctuation or something to indicate that we're done and the next line is a new code. So if you span lines, you've actually broken your code in half. If you do this, you've broken your code. You can see it turns black because it actually reads this is one command and this is one command. You can, if you want to, I won't. You can turn on delimiters if you like them. There, it's going to use a semicolon as a delimiter for everything going down, or you can turn it off by setting a carriage return, CR, which is just normal. That's one way to do things. Sometimes Stata will wrap, and if it's wrapping something, you'll know because it doesn't have these little numbers here. So for example, if I have lots of text and it just wants to look better, see here, it looks like it's a break, but it's not because this is all line 58. So in that case, this is still one line. The other thing you can do if you want to just on a one-off, not break lines, is do 3 / and continue, and it will read that as one line of code. It's not really applicable in this course, but just something to keep in mind if it's driving you crazy that a new line, a carriage return starts a new line of code, because that can be confusing when you're switching. All right, other things that you can do. You can also use keyboard shortcuts or things from the menu to also comment things in and out. And in my case, if I'm using a Mac, I hit Command and a / and I can command out / and it will command out chunks of text as I like. All right, so I comment out. Okay, so basically then now we have a text file that we can work with. We can write notes to ourselves, and then we have commands. Commands will be highlighted in blue to indicate that Stata is going to try to use them. The black will have the options and things like that, and then file names will usually be highlighted in red. You can see if you don't miss a quotation mark, something will look wrong, and so that kind of just gives you a little clue for how things are working. When you are working in a do file, Usually what we want is everything to be the same across everyone's computers except the location of our files. So what I might do is start by setting a working directory, CD for change directory, and then I'll put where my data is. This is not where my data is, so I'm going to comment that out. And I'm going to go to where my data is, which hopefully I haven't lost my file. I might have lost my file. I'm going to put it back up here. So mine is here. I can see the full file path down here. I can also take this, right click, hold the option key, and then I can see where my path is. So what I'm going to do is I'm going to change directory. I'm going to put quotation marks just in case I have spaces. I'm deleting the file name, and now I have a directory. So what this is going to tell me when I run this, which I can do by just highlighting it and hitting Shift Command D, is it sets my working directory here. This dot indicates that I sent it a command, and then this is the output. And then I can check my working directory to make sure that it worked by typing pwd. One thing to note here, if you have any bit of your command selected and you run it, it will run the whole line, because again, one line, one command. So unlike something like R, you can't run part of a line. You can only run the whole line. All right, so now I'm in here. Now I want to use this data, so I can use my command here. Use, this means open the data file. Here's the name of the data, and then this means to erase any data from my memory, because we can only have one at a time. Again, I can run this whole file from start to finish. I can select. I can also do this, and I can just run one line at a code. Now I've loaded the data file, and I can see the data file here. And there's a few things that are worth doing. You might look at the different types of variables. You might type browse, and you can visualize them and actually see what they look like. This can be extremely helpful. You'll notice that a lot of these are blue. That means they have a label. So the value here is Georgia. It looks like Georgia, but the value is actually 13. It just has a label called Georgia, but its value is 13. So that's what blue ones are. Black is going to be, they are a number, see 45, no label. And you'll see some reds, and those are string variables where the value is the text itself. In this data, I don't have any string variables. There aren't any red ones. You can also use some of the commands we used before to get a sense of the data we have. And it's a good idea to just get a sense of, for example, here's our year. It goes from 24 to 24. It never varies. That's a good sign. You can see over here we've got some wacky numbers. This suggests that we might have to watch out for some codes that reflect maybe don't knows or NAs. It just gives us a sense of sort of what's here and what we're going to be working with. One thing I should note, this data comes from IPUMS. So this is the American Community Survey from IPUMS.org. And so in general, I'm going to try to provide full documentation, but if you were to go here and then go to the census, you'll be able to find all the documentation you could ever want, probably too much, to help you walk through all of this. One thing we still want to do is use our logs. So we're going to keep logs as a command, and basically we're going to have a log. What's going to happen is the log's going to open right there, and then all this stuff in here is going to be logged, and then we can close the log. What this means is that when we have our log at the end, it's going to be a very concise, small file that just reflects the stuff that's important to us. It also means that when we troubleshoot and have errors, that might be in our log, but at the end we can do a fresh run. I put this command here. This is capture log close. What we want to do is, if we have a log open, so let's say I have a log open like this, I'm just going to do it so you can see the log is open, it's running. Just put some extra text in there, there we go. And we can go see in our log file, see it's recording everything that I've done here. If for some reason my file ends, there's an error, I'm returning to what I was working on before, and I try to run this command again, I'm going to get an error that the log file is already open. Now, if my do file goes all the way to the end, then it's going to run log close, and that will close the log, and then I can open a new one. But because sometimes our code will break halfway through and the log never gets closed, this can be a problem. So what we do is we put a log close at the beginning, but if our log is closed, you can't close something that is closed. So what we do is we just tell Stata to leave us alone by typing capture. Essentially what it's saying is there's going to be an error code returned. So you can see it here, it's R606. I can click on it and learn more about it. But what I can say with capture is basically just kind of eat that return file code, capture it, and just keep going. So basically it's a awkward way of saying if it's closed, if it's open, close it, and if it's closed, just move on. So basically, I don't like to type this every time. This is a lot of stuff to remember. So what I'll do is I'll just use this template. Get rid of this nonsense, we don't need that. I'll update with the data file I'm going to use, and then I'll just put all my new analysis here. Then, if I'm doing something else, maybe I go back to my file folder, which I've already managed to misplace. There we go. I go back to my file folder and maybe I say, okay, I'm going to duplicate this. I'm going to copy and I'm going to paste it. And then I'm going to make this one. And then maybe I duplicate it again. So I just keep editing it as I go through. What I recommend doing is, in general, a few things. One, we always want to do our work in a do file. If we're kind of working in the command line, because we're kind of playing around with codes, right? I'm summarizing BPL, and then I'm kind of tabbing BPL, and I'm getting a sense of it and that sort of thing. And I want to just play with it, but I want to get those commands back. One thing I can do is I can just copy the commands and I can paste them back in here. There are other shorter ways of doing this. Or I can just put the stuff in here and play with it here and then run it back. But basically we kind of want this to be like the polished version of our analysis such that when we're all done, we can go back to the start and run it through. The other thing, it's a very good idea to provide lots of comments. This is useful to yourself. This is useful to me. It's useful to everyone. The other thing is that we are going to start with this data file, and then we're going to do a bunch of analysis. Because all the analysis we need starts from the beginning and just proceeds, we don't need to save on top of this. We don't need to replace this data file. Essentially, we're going to think of this as our raw data and we're going to preserve it. We're not going to make changes to it. And then when we do something else, that file remains sort of untouched. If ever we needed to make a new data file, we wanted to save the work, maybe we did a lot of cleaning and it takes a lot of time to process, maybe we'll save a different named file, but we try not to overwrite the raw files. That is, your ACS 2024 2% should be the same file that you downloaded. And if something goes wacky, you can just download it again, which is better than saving on top of the file. Essentially, we don't need to. If we save everything we did to change the file, then these things are going to be the stuff that's important, and this file can stay untouched. We talked a little bit in the first lab about getting help and reading these files. Keep working with them. I also recommend Google, ChatGPT, etc. There's a lot of resources to help understand and work with Stata documentation. The lab today actually doesn't have anything that is especially new conceptually, except that we are building on this do file, building our comfort, and then there's a few additional commands which you'll see over here. A few of them that are especially helpful. Let's go pull over here. We've been working with tab, right? One thing you'll notice here is that this looks like the variable is called white. It's not. Like I had said earlier, it's labeled. One way you can see that this is the case is you can tab race no label, or rather tab race no label, and you can see the values that correspond to this. The other thing you can do is you can browse your data and look it up this way, and you can see what the different values are underneath. One thing you might also want to do, if we take something, let's look at like income, total personal income. So I'm summarizing inc tot. I typed sum instead of summarize because you can abbreviate, and I get some data here. One other thing you might want to use is called tabstat. Tabstat is helpful because if you just type it like this, you can get the mean overall very quickly. You can also type by, and it will give you that statistic separate for each value of the thing you put in by. So for example, if I tabstat by race, it will give me the mean income for every single race. Now, one thing to think about is why these numbers are so high. It probably has something to do with this. That's something worth looking at and thinking about later. The other thing that's nice about TabStat is you can also change the stats that you have. So for example, you can have a mean, you can have a count, you can have a median. There's a whole bunch of additional options. And to get at those, you can type help TabStat, and you can see, if we scroll down to statistics, all the different statistics you can easily get. You can get them in aggregate and you can get them separate. We're going to work with generating variables and the expressions that we worked with before, and then we're also going to create some basic graphs. If you want to do just a simple graph here, that's great. If you want to make it look prettier because of either by playing with the help files, etc., you can also do that. I'm going to stop here in terms of the orientation. But in general, what I'll ask is that as you go through, make sure that you're working in your do file. If you have a whole bunch of commands and you've kind of forgotten, what you can also do is you can select them. I'm just using the Shift key. I can send them straight to my do file editor, and that way I don't have to retype things. So we want things to be efficient. So that can also help you. I'll stop here. Good luck with Lab 2, and I will see you soon.